Alright, this is my chapter 15 reassessment. Came up with a problem here. We're going to be trying to find the force on the ball by this strip of copper wire parallel to the x-axis. So the length of the wire is big L. The distance from the wire from the ball here is little r, and the charge on the ball is a negative charge, so we have negative big Q. And the radius is big R. I don't think it really matters, but so we start off with something simple that we know it's going to be the force of the ball is equal to the force of the wire. So from there, I try to break it down into tiny little steps of everything that ran through my mind when doing this problem. So then I have force is equal to QE, the charge times electric field, and so that brings me to our next step, which is the force on the ball is equal to charge of the ball times electric field of the wire. And we know the Q of the ball, which was given up here, the charge right here, 3 times 10 to the negative ninth. So we need to find E wire, the electric field of the wire. So that's going to be, since it's parallel with the x-axis, we use this right here, 1 over 4 pi E naught times 2 QL. I think we use 2 QS, but here I used the length as big L over, I know you can't really see it, but that's little r to the third, so little r cubed. So just to kind of combine everything that we know from these 4 steps, we have this: F ball equals Q ball times, and then this formula here for E wire. So we pretty much know everything here except for our little q. So what is little q? That's what we need to find out here. So we know E net is pretty much, you add up all of your electric field that's going on in this whole system here. So we have E ball plus E your positive charge of the wire, and then E negative end of the wire. So we broke it into 2 sections there. So we know our E net is always going to equal 0, and we get this here. Let's see, your L is divided by 2 since we broke it into 2 sides. This is just given as the basic electric field formula here. Whenever you solve for little q, it's kind of a pain to do, but this is what you get here for little q, q over 8 times L over R squared. And when I plug in my numbers, I get 3.0375 times 10 to the negative 12. And let's see, making sure I'm not leaving any random things out that I'm not explaining very well. Okay, I don't think so. And then from there, the book breaks it down a lot farther for whatever reason I don't understand, because you can get the right answer, I believe, just from taking this little q and basically plugging it up in with this right here that I came up with. Since we already know our big Q, bam, that goes there, and plug in the little q there. So I have this formula here. So I have all these numbers. When you do the math and all that, you get this number, and everything cancels out except for the newtons, which is of course our measurement of force.